Hello everyone, and welcome to Section 3. Number needed to treat and harm. In the last section, we learnt about odd and risk ratios and their usage. In this section, we will learn about NNT, the number needed to treat, and NNH, number needed to harm, i.e., the number needed to treat and harm. Number needed to treat, NNT. The number needed to treat is a popular way of demonstrating the effectiveness of a treatment. NNT is a derived statistic that tells us how many patients must receive a particular treatment for one additional patient to experience a favourable outcome, such as treatment response. The number needed to treat is the number of patients you need to treat to prevent one additional bad outcome, death, stroke, etc. For example, if a drug has an NNT of 5, it means you have to treat 5 people with the drug to prevent one additional bad outcome. The NNT for a study can be calculated by finding the reciprocal of the difference in risk between the two groups. In the next slide, we will discuss in detail how to calculate NNT. Calculation. The number needed to treat is the inverse of the absolute risk reduction, the ARR. The ARR is the absolute difference in the rates of events between a given activity or treatment relative to a control activity or treatment, i.e., control event rate, the CER, minus the experimental event rate, the EER, or ARR equals CER minus EER. The control event rate, CER, is the proportion of participants in the control group that have the outcome, whereas the proportion of patients in the experimental treatment group who are observed to experience the outcome of interest. NNTs are always rounded up to the nearest whole number and accompanied as standard by the 95% confidence interval. For example, if a drug reduces the risk of a bad outcome from 50% to 40%, the ARR equals 0.5 minus 0.4, which is equal to 0.1. Therefore, the NNT is equal to 1 divided by ARR, which is equal to 10. Number needed to harm, the NNH. The NNH shows how many individuals would need to be treated with the drug in order for one to show the harmful effect. NNH also refers to the average number of patients who need to be exposed to some risk factor to cause harm in an average of one person who would not have been harmed otherwise. In other words, the number needed to harm, NNH, is a derived statistic that tells us how many patients must receive a particular treatment for one additional patient to experience a particular adverse outcome. NNH shows how many individuals would need to be treated with the drug in order for one to show the harmful effect. The formula to calculate NNH is, whereas IT refers to the incidence rate in the treatment group, and IC refers to the incidence rate in the control group. Example: NNH. Suppose a doctor tests out a new drug designed to lower blood pressure and finds that 1 in every 250 patients experiences a heart attack as a side effect. The number needed to harm for this particular drug would be NNH equals 250. The higher the NNH for a given drug or treatment, the lower the risk factor of the drug or treatment. For example, if drug A has an NNH of 250 and drug B has an NNH of 600, drug B would be preferred because it only harms 1 in every 600 patients, on average. For example, suppose 5% of patients who use a new blood pressure drug experience a heart attack, compared to 3% of patients who simply took a placebo. We would calculate the number needed to harm as This means that 50 patients, on average, need to be exposed to this drug in order for one of them to experience a heart attack, who otherwise would not have experienced the heart attack. In this section, we learnt about NNH and NNTs, their importance and their usage. In the next section, we will learn about the importance of life tables and Kaplan-Meier curves in medical research.